Well, welcome to Marcus Maths. Today I'm just going to give you a little tutorial on prime factorisation. Okay, and what this is actually also known as the Fundamental Theorem of Arithmetic, and you could pick any number you want that is greater than 1. So let's say we pick 5. 5 is a prime number. What's a prime number? It's any number that can only be divisible by 1 and itself. Okay, so 5 is prime. What about 6? 6 is not prime, or in other words, it's called a composite number. 7, prime. I'll write here prime as well. 8, composite. 9, now don't suddenly think that any odd number is prime, because actually 9 is composite because it goes into 3 as well. Okay, and 10, composite. So any number above 1 is either prime or composite. And this is where prime factorisation comes into it, because if I pick any composite number, I can get this number by multiplying just prime numbers. So who can think of how to multiply 2 or more prime numbers to get 6? Pretty easy one, this. 2 times 3. Or 3 times 2, it doesn't matter that they are, ignore the order. Now, what about 8? How can we get 8? We might be thinking 4 times 2, but 4 isn't prime. But hey, what about 2 times 2 times 2? 9's an easy one. 3 times 3. And the fascinating thing about this is that there is only one unique set of prime factors for any number. So if I was to pick 100, you may think, well, there's loads of ways of getting 100 by multiplying prime numbers. Well, actually, there isn't. There's only one way, and it's multiplying these 4 prime numbers. Okay, and like I said, this is also called the Fundamental Theorem of Arithmetic. And I normally work this out by using what I call a factor tree. So let's just say that I wanted to work out the prime factors of, let's say, 200. Okay, how would I do that? Well, first of all, think of 2 numbers or 2 factor pairs that equal 200. Make it easy. So you might want to make it 20 and 10, because 20 times 10 is 200. Now, take your 2 factor pairs and break them down. So what 2 ways can we make 20? What 2 numbers make 20? You could pick 10 and 2, or you could pick 5 and 4. It doesn't really matter. And how could I make 10? Well, 5 and 2 seems the obvious one. Now, to see what's happening here, I'm now starting to get prime numbers. The only one that isn't there is 4. Well, that's pretty easy. It's 2 and 2. So if I now circle, or underline rather, all of my factors now, which are prime, I get 5 times 5 times 2 times 2 times 2, which we can combine into 5 squared times 2 cubed. And there we go. So in any GCSE questions in exams, they'll often ask you for this, where they'll ask you for example, write 36 as a product of its prime factors. So 36 has loads of factor pairs, 36 does. I would think straight away as 6 and 6, but they're not prime. But I can then partition 6 into 3 and 2. And again, you've got 3 and 2 here. We could say these are times in. And suddenly we have our prime factors. What do we have? We have 3 squared times 2 squared. So have a look at this. It's really interesting stuff. You could pick any number you want and use this factor tree idea down here, and you'll find that, yes, there's only one unique way or only one unique set of prime factors for any number. All right, thanks for watching.